Alright guys, so welcome to Blue Tech Empire Python tutorials. In this video, we are going to be looking at mutability, immutability, and the garbage collector. So these are very important terminologies in Python. So we are going to be going straight to the video so we can be able to look at what this all mean. Alright, so now I'm going to be following the content from the channel so I don't leave anything out, So following what is written on the channel, it says in Python, when a value of an object cannot be changed, we say the object is immutable, while objects whose value can be changed are known as mutable objects. Now, technically, almost all Python objects are immutable. In Python, numbers, that's integer, float, and complex. Strings, booleans, and tuples are immutable, while lists and sets are mutable. We are going to be looking at all that. So let's now look at some examples. Now consider the following. I get into Python. All right. So consider the following. We have value equals to 30. We have max equals to 40, and we have now we have value equals to 30, max equals to 40, we have value equals to hello or whatever string, and value equal to stop. Now I'm going to do some explanation here before going back to the channel so you understand thoroughly what we're talking about. Now in this case, we created 4 variables: value, well, 2 variables, but later we assigned hello to value, and later on we assigned the string stop to value. Now what happens now? Initially, value is an int. What happens is Python creates an object like we learned in the last video. If you haven't watched the last video on variables, I will advise you to watch it before continuing this video, because this is like actually a continuation of the last video, and you will be able to understand what variables are all about. So in this video, we already assume you know about variables. You can watch video 3 to get more about what variable all means. So we assigned 30 to the variable value, or to the variable name value. What Python did is it actually created an object in memory. It discovered 30 is an integer. It assigned the type integer to that object, and it assigned the reference count of 1 to that object. So right now we have value equal to 30. Now the value points to that object in memory containing the value 30. Sorry, we use the name value. Now max is another variable name. It actually points to an object in memory which has a value 40 and is an integer. Now later on, we actually came and said value equals to hello. The question you want to ask is, did Python go into the memory location containing 30 and changed it to hello? Or in the case where we said value equals to stop, did Python go into the memory containing hello and change it to stop? No, Python doesn't do that. Now let's try something. Let's say id value. Let's see the memory location of all these stuffs. Max. Now, initially what happened is, when Python created the object 30 and assigned the value as an int, and created for max, it created an object 40, an attempt to assign a different value to the value is wrong. We actually had to use a different name, but to the variable name value, what happens is Python actually breaks the bond or the reference between value and 30. So the variable name or the tag value would not longer point to the object containing 30. What happens is Python breaks that bond and now points value to the new object called hello. After that, when the interpreter reaches this stage, Python breaks the bond between value pointing to an object containing the string hello. Python now breaks that bond and points it to a new string called stop. So now value points to stop. You're going to be asking, what happens to the hello in memory? It's abandoned. it's abandoned in memory. In the other case, 30 is also abandoned in memory. What happens is, for a while, Python is going to understand that maybe sometime in your code, you're going to create another object called maybe 30 or so. So let me show you what actually happens. Now let's do some work here. Okay, let's say var1 equals to 40, var2 equals to 40.5. Now, what happens here, if we attempt to say, let's check first the ID of var1. Now, let's check the ID, like the memory location of var2, or the address of var2. All right, we now know these both addresses. Oh, so var1 has an object 40 located at an object which contains the value 40, and it's an integer, while var2 contains an object with a value 40.5, which is a float because it has a decimal point. Now what happens is, we see, oh, var1 is in the address var1, the memory address of var1 it's this, and the memory address of var2 is this. Now let's try something. Let's say var1 equals to 60. Now let's check the ID of var1. Now if you look at it, it actually changes. var1 equals to 60, what happens is Python created a new object at this location, okay, and assigned var1. It breaks the bond between this var1 and 40, so var1 would no longer point to the object containing 40 as a value. It will now point to a new object created in memory called with the value 60. So now the reference count of the object containing 40 is 0. For example, I told you a reference count indicates how many variable names are being pointed to an object. Python keeps that. Why? Python keeps that so it can know when no variable longer points to an object. For example, in this case, var1 was pointing to the object 40, but at this point, var1 now points to the object 60, which means 40, the object containing 40 has no variable pointing to it. At this point, its reference count is 0. Now, Python is going to leave that object in memory for a while. Might be some time within your code. Maybe you're going to say num equals to 40. In that case, if you say id num, you see it has the same value as var1, the same memory location as var1. Why? Because at the time we stopped var1 from pointing to this location, Python kept it in memory. So later on in our code, when we said num1 equals to 40, Python did not create a new object with a value 40. What Python do? Rather, it remembered it already has an object in memory, and it pointed num1, that's the variable name or the identifier num1, it pointed it or referenced it to that memory location. So you see the memory location here, and this is equal. So it means Python did not create a new object 40, rather it used the old object. So I want you to understand the concept whereby Python can change the value. For example, if you say let's say num1 equals to 25, 24, and num1 equals to 50. What happens is, clearly Python creates an object, stores 20, the value 24 there is an integer, then it assigns the tag or the variable name num1 to that location. Now, when you assign another value to num1, what will Python do? Python will not change the value in that object it created. Why? We say in Python the object is immutable. It means its value cannot be changed. Numbers in Python are immutable. It means if a number is within an object like 24 or 24.5 or 2i plus 3j, that's a complex number, its value can never be changed. If you assign a new value to that variable name, Python just creates a new object and it detaches the reference from the old object to the new object. So num1 now wouldn't point to the object containing 24. It will now point instead to the object containing 50. What's going to happen? The object containing 24 now has no variable name pointing to it. So what happens after a while, if Python realizes no variable or no variable has been created, yes, to point to that object, maybe later in our code, we did not create any 24. So after a while, Python takes it off. Python deletes it off memory. Now, what is the part of Python that does this? We call that a garbage collector. Running within the background of a Python interpreter is what we call a garbage collector. The work of the garbage collector is actually to go around the Python to look for the memory accessed by different Python scripts or by Python script it's currently executing. It looks for all objects with a reference count of 0. Remember, we said if you say A equals to 30, B equals to 30, and C equals to 30. Remember, we said if you find ID A, ID B, ID C. Remember, we said so. We see ID A, ID B, and ID C are all equal. It indicates they all point to the same reference or they all reference to the same object. Let me put it that way. The variable A, variable B, variable C, Python created only one object and then referenced all these variables or pointed these variable names to that object in memory. So as you can see, ID for A and B and C are all the same, which means they have the same memory location. Now, that object has a reference count of 3. 3 because 3 variables point to an object memory which has the value 30. A is 1, B is the second, C is the third. So now if we say A is equal to 50, 40, B is equal to 60. Now A now points to a different object because Python will create an object 40, maybe not because we had bar 1, but let's just say Python is going to create a new object 40, or Python is going to point A to an already existing object, maybe 40, this one or both. But let's say now A is no longer going to be pointing to the object containing 30 as a value, and B is no longer going to be pointing to that object. At this point, the object with the value 30 had a reference count of 2 because it only had B and C pointing to it. After this line was executed, it only had a reference count of 1 because at the point only C points to that object. If we now say C equals to 100, at this point 30 has no reference point or reference count. The reference count is 0. Once an object reaches a point where its reference count is 0, it's allowed in memory for a while. If no variable is assigned to it at a later time, it's garbage collected. It's deleted from memory. We call the process of deleting an object an unused object from memory. We call that process garbage collection. So you should understand behind a Python interpreter is a garbage collector. It's a software or a program that actually runs through memory being accessed by your Python scripts, and it checks any part of the memory or portion of the memory with a reference count of 0, actually deletes it from memory. So I wanted you to understand the meaning of garbage collector. Now, the garbage collector only works with immutable objects. What does that mean? It also works with mutable objects. For example, if you create a list and there's no variable pointing to the list after a while, it's going to be garbage collected. But like we said, technically, all objects in Python are actually immutable. So now, I'll try to repeat the meaning of immutability so that you understand perfectly. Immutability says if, for example, you say A equal to hello, and later on you say ba equal to hi. Now, the Python creates an object in a string object and which has the characters hello. It points a to that object in memory. Now, when you say a equals to hi, Python is not going to replace the value within the object with a new value hi. No, Python is going to create a new object called hi. It's like wastage, but it's not really wastage. It's going to create a new object called hi and now point a to that new object. So this hello object will have a reference count of 0. And why can't Python replace the hello with hi so that A just keeps pointing to the same object but with a different value? It's because strings in Python are immutable. Once they are created, their value cannot be changed. We say they are immutable. Same like numbers. If you say num1 equals to 10 or 20, and you say num1 equal to 20.5. What happens is Python, this was already an integer. Let's say we say num1 equals to 30.4. Let's forget about this line, let's start from this line. For example, if we said num1 equals to 20.5, Python creates a float object and it now stores the value 20.5 within that object. What happens is, next, if we say num1 equals to 30.4, what happens is very normal. What happens is, at this point, Python wouldn't replace the 20.5 it saved earlier in num1. What it is going to do, it is going to create, it's not going to replace that 20.5 with 30.4 because numbers in Python are immutable. Their value cannot be changed once they are created in memory. Instead, Python is going to create a new object, assigning the value 30, and now point num1 to that new object and break the bond between num1 and 20.5. So num1 is now going to point to a new memory location. Let me show you. Now we say num1 equals to 50.6 id num1. Here is the memory location. We say now num1 equals to 50.7 id num1. All right. What do you realize? Num1 now has a new address. Why? Because it points to a new object. It doesn't longer point to this 50.6. It points to a new object that was created with the value 50.7. So at this point, num1 can't be replaced, the 50.6 object can't be replaced with a new value 50.7 because in Python, numbers are immutable. Their value cannot be changed. Now, in Python, numbers, strings, and we're going to read right now. Now, like we said, when the Python interpreter processes this script, it first creates, watch this script on the right hand side, it first creates two integer objects, that's value objects, one with a value 30 which is assigned to the identifier value and another with a value 40 which is assigned to the variable mark. These two in objects will have a reference count of 1 each, yes, because they have only one identifier pointing to them. When the interpreter reaches line 3, that's value equals to hello, it creates another string object in memory with the value hello. At this point, it will detach the identifier value from the first object and assign this identifier. It's going to detach it from the object 30 and assign it to this new object hello. This new object will have a reference count of 1, while the old object will have a reference count of 0. The first object will stay in memory for a while, yes, for a while, and so in object for a while, though its reference count is 0, because you may create another variable with that same value and Python is just going to point that variable to the old object. After some time, if no identifier is assigned to the first object, it will be wiped from memory as the Python interpreter deems it as no longer useful in the code. So like wastage of memory, the process whereby an object with 0 reference count is wiped or removed from memory is known as the garbage collection. Behind the scene, when your Python code is being executed, the Python interpreter by the Python interpreter, there is a program running in the background known as the garbage collector. This program searches for objects that have a reference count of 0, like I explained earlier. Once an object has a reference count of 0, meaning no variable points to it, or it has no variable identifier attached to them, the garbage collector will consider them as garbage and remove them from memory. It actually takes some time because the garbage collector runs once in a while, not continuously. Moving back to the code at the top, when the interpreter reaches the final line, it will create another string object. Since the object stop doesn't already exist in memory, this object here, since this line is going to create a new object. So since the object stop stop doesn't already exist in memory. When this new object is created in memory, the identifier value will be detached from its previous object hello and attached to the new object stop. The reference count of this new object will be 1, while that of the third object will be 0 and will soon be a candidate for garbage collection. Here is a schematic diagram trying to explain the concept. Here we have a statement var1 equals to 30, var2 equals to 40.5. What happens? Python creates an object in memory, assigns the type int to it, gives it a reference count of 1 because only var1 is pointing to it. That's the identifier var1 points to it. The next line, Python creates another variable, another object in memory. In this time is a float, 40.5. And what will Python do? 40.5, it points the variable var2 or the identifier to that object in memory. Now, going down in the code, we see a new variable of var3 equals to true. What happens is Python creates, because true does not exist in memory, Python creates a boolean object like we saw, or like we are going to see. We are going to talk about boolean objects. A new boolean object assigns the identifier var3 to that new object in memory. Now Python sees var4 equals to hello. Hello doesn't exist in memory. Python creates a string object with a text or the sequence of characters hello and assigns a reference count of 1. Now we set var5 equals to 30. Python already has 30 in memory, which is only referenced by var1. Python now assigns var5 as a new reference to that memory 30. So at this point, var1 and var5 reference the same memory with the value 30. Now var6 equals 30. Python already has an object with the value, an int object with the value 30. So Python just reference or point this variable var6 to that same object. So as you can see here, var1, var5, and var6 point to the same object in memory. That's an integer it has now 3 reference counts. That's var1, var2, and that's var1, var5, and var6. Now, moving down, we see var1 equals to 10.2. Now, 10.2 doesn't exist in memory, so Python creates it. But remember, var1 was pointing to the object 30, which now has two other variables pointing to it. Python detaches var1 from that object, leaving it with only 2, that's 5 and 6, and now points var1 to the new object it creates in memory. var1 now points to 10.2. var5 equals to 2000. Python detaches var5 from the 30 reference. It means it's left only with 1, which is var6. Python creates a new int object 2000 because it's new, it doesn't exist in memory. Python now points var5 to that new object 2000. Now we say var2 equals to John. Now remember, var2 initially pointed to the object 40.50. Once Python detaches, but John doesn't exist in memory, so Python creates a new object John and points var2 to that object. Now var2 has been detached from this object where it points to 40.5, which means this object now is a candidate for the garbage collector because its reference count is 0. Now at this point we say var3 equals to 40.5. Oh, a new variable now has been created to point to that reference which has a count of 0. So what happens is, since 40.5 already existed in memory, though it had a reference count of 0, but Python left it around for a while. And luckily for Python, we created a new variable var3 to point to that 40.5. But remember, the variable var3 pointed to a boolean true, remember var3 pointed to a boolean object 2, Python will detach var3 from that boolean object and now point it to a new object, that's var3, from to the new or the old object 40.5. So while this will gain a reference count of 1, this boolean object will have a reference count of 0. Now var4 equal to 10.2. Now we assign var4. var4 recently was pointing to an object containing a sequence of characters hello, that's a string object, but now we detach var4 from there to an old object var pointed to by var1. Now only var6 points, that's var1 equals to 10.2. Now we point var4 to that same object. So the end result is var1 now points to 10.2 along with var4. You see var4 also points to 10.2. Now var5 points to 2000. var2 points to John, we know. var2 points to John. And var3 points to 40.5. We see var3 now points to 40.5, and we have already talked about var4. So I'm just trying to show you how objects are created. You should know floats, all numbers in Python are immutable. For example, if we have a equals to 3 plus 4j, that's 3i plus 4j, complex number, and we find the id of a, you see a now is 1. If you now say a equals to 4 plus j, 4 plus 1j. Now if you find id of a, you find it changes, which means numbers too are not immutable. A new object was created. The 4a was initially 4 plus, that's 3.4j. Python did not replace that complex object with a new value 4 plus 1j. It actually created a new complex object, detached a from the old complex object to the new complex object. Why? Because it cannot change the value. Why? Because this is not mutable. Like objects are not mutable. Like objects are not complex objects are not mutable. They are immutable. So that's just the basic of mutability and immutability. So we are going to move on. So now to show you one more stuff about immutability, like we told you lists, we are going to talk more about that in the next video, but we should know tuples are immutable, which means you cannot change the value of a tuple. For example, I'm going to show you an example. We are going to look at data types in the next video, but this is just a quick example for you to understand what I'm talking about. So, for example, if you have a tuple called a equals to, remember tuple is just like a list of items, but they are within curve, they're within brackets. So we say it. Now, if we try to change the value at index 0, we are going to learn all this in the next video, but if you know it, you can follow up to also object does not support item assignment. Why? Because tuple are immutable. You cannot change, once you create 258, you cannot change the value of a tuple. You cannot change any of these values. But look at the list. For example, let's say this was a list L equals to that same tuple, but here we use square brackets 2, 5, 8. In this case, we can say list 0, we can change list 0 to maybe 4 equals to 5. It works, and we can say print L. You see, it's a new list. It changed to 558, which means we're able to change one of the values in a list. So as you can see, it still points to the same memory location. For example, if you have a list which has 2, 4, 6, 8, let's create a list with the values 2, 4, 6, 8. Now let us get ID of the list, the memory location we see. Let's try to change the value in the second index, like 1 equal to maybe 200. Now let's get ID of list. even though we changed one of its value, you discovered a new object was not created, the ID will still be the same. See, it's still the same. So even though we changed an item in the list L points to the same object. Look, it pointed to the same object at creation, at the same memory location at creation. Now we changed one of its value. If it was immutable, Python will have created a new list with a new value, with these new values. Let us print list to see the new value. Print this new value is 200, but Python just replaced this and still left the list intact. So you can see the list, even after assignment, the list still has the same memory or address, which means it still points to the same object in memory. But this does not happen with a string. For example, if you have the string, let's say text equals to welcome, welcome. You can get the text maybe in the second index like this is L012 L, but you can't change the text in the second index to maybe P. It's going to tell you string object does not support item assignment is because string objects too are immutable, which means you cannot change any text character within a string once created. If you say text equals to hello or hello and say id text, and later you say sorry id txt, and later you say txt equals to hello, you just change one value and get the id txt. What happens? You realize it still points to this, it changes, abandon the old object containing hello, created a new object, it destroyed the link between the old text and hello and pointed it to, now it references it to the new object containing hello. So it's just to prove to you that strings are immutable, tuples are immutable, numbers are immutable, but stuff like lists, sets, like we're going to see later, and dictionaries are immutable. But we can check something. Let's say we have a dictionary. Let's clear this off, exit, and let's see ls. Let's say we have a dictionary called, a list called L1 equals to 2, 4, and 8. Now let's find the ID of L1. Let's see if we can find the ID of a particular index L1, L1, 0. All right, I want you to look at something. Now, take a look at this. If we say we can find the ID of all the indexes within the list, for example, this is the ID, this is the memory location of 2 within that same list. If we can find the memory location of, this is the memory location of 4 within that list, and this is the memory location of, please, this is just extra stuff. If you don't understand, you don't need to worry about it. Here is the memory location of, lastly, this is the memory location of 8. Now, I want you to see something. When we say technically, all Python variables are immutable, what happens when you create a list with 2, 4, 8? Here technically L10, it's a variable that points to the first immutable. Remember, 2 is immutable. Is the this that points to the first image. So what happens is list contains an object that has objects. So the first object is immutable, it points to the value 2. The second object is immutable, is called L11. That's the first index, the second index. It points to the value 4. And the third index is L18. Let's see, if you say L10, I want to show you that that's the value. It gives you 2. L11, it gives you 4, and L12, it gives you 8. So this L1 along with the index operator are like immutable values. Say for example, we change we change L1, let's change L11 to 16. L11 equals to 16. Now let's print our list. Print L1. Now notice it's changed, but let's see whether L11, this L11 still has the same memory location. Let's see. ID L11. Now take a look. Initially, L11 has the memory location. This was the memory location. Note that it has changed. Why? Even though we say a list itself is immutable, we just mean the memory location that is pointed to by L1 will always remain the same. But within that memory location, we have several objects. Within that object, L1 points to, which will never change. We have other smaller objects within it, and they are called L10, L11, L12 to L1 whatever, depending on the length of the list. Now, once we change one value, for example, if we say L11 equals to 20, this reference will cut. This reference was pointing to an integer object 4. If we now point it to an integer object 16, like we did here, it's going L1 normally is going to be that's the link between L11 and the object 4 is going to be broken. A new object 16 will be created in memory, and L11 will now point to that new object. That's why you see L11 initially was here, and later on L11 had a different object, which means technically a list is an immutable object containing is a mutable object containing immutable objects. For example, this list is an object, but within this list it has 3 immutable objects, 2, 4, and 8. If we change any of these values, the L, for example, let's say we change L12, that is currently 8, for example, L12, let's see the value, it's 8. Let's look for the ID, the memory location of L12. Sorry, the memory location ID L12. Here is it. Now let's change L12 to something else. L12 to be 200. Let's print our list. You see the last item is now 200. L1. Now let's look if the memory location, this same stuff we wrote here, let's see if it still points to this location. No, it has changed, which means initially we had 8. Initially we had this last variable value as 8 in this list. Where is the list? Initially in this list we had this 200 as 8. Now when we assign a new value to it, L1 was initially pointing to that immutable integer object 8. It will now change. It is linked to that object will be broken, and a new object was created. The new integer object 200 was created. L12 will now point to that new object. So I just wanted to show you guys, don't worry if you can't understand this last step, that a list is a mutable object containing immutable objects. Or somehow I just want you to understand, technically behind the scene, all objects in Python are somehow immutable. So that's all for these tutorials. In the next video, we are going to be looking at multiple assignments. For example, um, I just want to say you can write A equals to B, B equals to C, which is equals to 30. What happens is Python creates an object in memory called 30, assigns C to that object, it assigns B to that object, and it assigns A to that same object. So instead of writing A equals to 30, B equals to 30, and C equals to 30, you can just write A equals to B equals to C equals to 30. Let's try with another one. Num1 equals to num2 equals to num3, which equals to 40. Let's see num1. You see it's 40. Num2, you see it's 40. num3, you see it's 40. Let's find the ID of num1. Find the ID of num2. You see they all point to the same location. Let's find the ID of num3. So here is just a way of creating variables. What happens is Python will just create an object, integer in this case because it's 40, create an object, point the variable num3 to that object, point, since num3 points to this object, you point num2 to where num3 is pointing, that's the same object, and point num1 to where num2 is pointing, that's the same object. So you can do multiple assignment on the same line and it still works in Python. So I just want you to understand, if instead of writing it on separate lines, you can conserve space by writing it on this. All right, so see you in the next video where we'll be looking at standard data types, that's numbers, strings, list, tuple. We are going to start with numbers and string in the next video. All right, so that's all for this video. See you later.